So, we're going to be talking today about measures of spread. So how far apart points are in a data set. So for example, here we have two data sets, which I have called data set A and data set B. And I want to know what is the mean and the median of both of these data sets. So if you look at the mean for this data set, you add up the numbers and divide by the total. And if you do it correctly, you're going to get a mean of 9, and the median number is 10. Okay, and here, if you add it up, 622 plus 25, 45 divided, yep. So here, the mean is 9, and the median is also 10. So these two sets both have the same measure of central tendency. So they both have kind of the same middle, but what they don't have is the same spread. And if you look at these numbers are kind of bunched together, and these numbers are spread apart. And saying what the middle is doesn't really encapsulate that information. So we're going to have a new type of calculation. And so the symbol we're going to use for that is going to be this. This is it's a lowercase sigma. It's a Greek letter, so it's a lowercase sigma. And the name of this thing, it's called the standard deviation of a population. That's kind of the official term. An unofficial explanation would be that it's the average distance from the mean. And it's not even really like an average like we know. It's a special average. It's something called a root mean square average. And I'll show you in a bit what that means. And the bigger the sigma, the bigger the spread. And there's also a symbol we could also do S, which is the standard deviation of a sample. Interestingly, it's not going to be exactly the same, but we'll get to that in a bit. So there's a formula for standard deviation. Which I have pre-written in my infinite cleverness. So the formula is that the standard deviation, the sigma, is equal to the square root of, and this part over here means the sum of, so we're going to add up, we're going to take all the values, we're going to subtract the mean, we're going to square it, and we're going to add all those up, and then we're going to divide by how many items we had in the set. And I don't expect you to know how to do this right away, we're going to actually go through an example. But this is the formula. The formula essentially tells us the procedure of how the standard deviation is calculated. So let's actually do an example. So this was the data set A from the beginning. So let's have the formula kind of sitting over here so we know what we're doing. So we're going to make a table. So we know that we're going to need our x values first. So the x values are, we're going to have a long table here. They're 6, 8, 10, 10, 11. Now what I've pre-written here, just to remind us, is that the mean is 9 and the number of points in the sample is 5. So then what we do is we take the values of x and we subtract the mean. And we're going to do that for each one of those points. So what we do is we take that and we subtract the mean. So 6 minus 9 is negative 3. 8 minus 9 is negative 1. 10 minus 9 is 1, which is 1 and 2. So the next thing we're going to do, if we look at it, we take those, this part over here, these are the deviations. Those are the deviations. And we're going to take the deviations and we're going to square them. So it's going to be x minus mu squared. We're actually not going to need that thing at the table. And that's going to give us, it makes it all positive, which is convenient, 1, 1, 1, 4. So we have 9, 1, 1, 1, and then a 4. What do we do with all that? We add it all up, right? So we're going to add up all those deviations. And so the summation of all those deviations is 16. And now we're almost done. So the formula, again, is that sigma equals the summation of the squared deviations divided by n and the square root of that. The summation is going to be equal to 16. The number of deviations is, the number of points, sorry, is 5. And so the standard deviation is going to be equal to the square root of 3.2. 3.2 square rooted is 1.79. So the standard deviation here is going to be 1.79. So that means roughly that on average each point is about 1.79 away from the average. So let's try the same thing now. Let's try it with dataset B. So you should probably pause the video and try this yourself. Make sure you get the right answer. So the x values are going to be 2, 4, 10, 13, 16. I'm going to go through this relatively quickly. Minus 9 is going to be negative 7, negative 5, 1, 4, 7. And then we're going to square it. So it's going to give us 49, 25, 1, 16, 49. If we add them up, it's going to give us 140, I think. Let's just double check it. 49 plus 26. Yep. So the summation equals 140. Which means that the standard deviation, which is going to be the square root of the summation, divided by, we still have 5 points, which is going to be 140 over 5 is going to be the square root of 28. And root 28 is 5.29. Which is equal to 5.29. So remember, which means that these points are on average, sort of, about 5.3 away from their average. And compared to this, the standard deviation was a lot bigger. So this had a standard deviation of about 2, and this has a standard deviation of about 5, which is what we'd expect. These points are more spread apart, so they have a larger standard deviation.